Okay, my goodness, I'm sure a lot of people were, well, not a lot of people because probably only one person is actually watching this, but somebody was screaming into their screen and saying, Alden, the derivative of 8 is not 8. So unfortunately, I forgot the derivative. Well, I didn't forget, but I just made an error here when I found the derivative. And then I ended up with something that didn't work, as you saw, and got stumped. Anyways, let's blame it on the illness. Okay, f prime of x equals 8 minus 7 x to the negative 1. So the derivative would be 0. Now my pen isn't working. 0 plus 7x to the negative 2, which is just 7 over x squared. Okay, yeah. So that was kind of a silly mistake, but I persevered, which is good. So we need 7 over x squared to equal 1, which means that x squared equals 7, which means that x equals plus or minus the square root of 7. But we're only going to choose the positive because we're on the interval 1 to 7. So that is my answer. X equals the square root of 7. Okay, there we go. All right, let's see here. Hot water. Oh, I know this one. It's dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t is given by a differentiable function. Selected values of C of t measured in ounces are given in the table above. Is there a time t at which C prime of t equals 2? Justify your answer. Okay, well, if C prime of t equals 2, we need to see if there is an interval 2 to 4, either the interval 2 to 4, or it could be a smaller subinterval of that interval where the average rate of change is 2. Because if the average rate of change is 2, then the instantaneous rate of change would have to be 2, right? This is 2 ounces per minute, right? Is how quickly it's dripping or into the cup or going into the cup. Okay, so, well, let's see. Let's see what is C of 4 minus C of 2. C of 4 minus C of 2 over 4 minus 2. Well, C of 4 is 12.8, and C of 2 is 8.8, and that's 2. And 12.8 minus 8.8 is 4. That's 4 over 2, which is 2. So, yes, right? We could say since essentially C of 4 minus C of 2 divided by 4 minus 2 equals 2. And we know that C is differentiable. The mean value theorem guarantees, I might have spelled that correctly, a time t, 2 is less than or equal to t is less than or equal to 4, such that C prime of t equals 4. So yes, we need to quote the mean value theorem, and we should use the language that they used. Is there a time t at which this is true? Yes, there is a time t at which this is true. Great. Find and classify any relative extrema for G. Justify your answers. Okay, let's look at what we were given. G prime, thank goodness, because I do not want to find the derivative here. And the nice thing is they already found the derivative for me. So now all I need to do is set this equal to 0 or find where it's undefined. But it's not undefined because this is a nice fifth degree polynomial. So let's find where it's 0. Well, it's somewhat obviously equal to 0. Maybe obvious, maybe not, but hopefully, where if x equals negative 1, or if x equals 3, right? Because negative 1 plus 1 cubed would be 0, and 3 minus 3 squared, I lost my pen, squared would be 0. So I can see that those are the values of x that make g prime 0, aka those are my critical points. So now I need to use the first derivative test. to analyze those points and see if they are maxes or mins or neither. So here's x equals -1. Here's x equals 3. I need to pick some test values on the intervals between these critical points. So I'm going to choose -2, 0, and 4. It doesn't matter what you choose as long as it's in those intervals, but I like to choose small things, and 0 is always an easy number to plug in. So g prime. If I plug -2 into g prime, I get a negative times a positive, which is a negative. If I plug 0, I get a positive times a positive, which is a positive. If I plug 4 in, I get a positive times a positive, which is also a positive. Okay, interesting. So what that tells me is G has a relative min at x equals -1. It's actually an absolute min, I think, because I think this function just increases after -1, but we'll call it relative. G has a relative min at x equals -1 since G prime changes from negative to positive at that point. Okay, and I don't really need to talk about x equals 3 at all because I know that it's not a relative min or max because g prime doesn't change sign. So I am just going to leave my answer like that. Okay. Function h is continuous and differentiable. The graph of h prime is shown. Okay, good. Make sure I know what I'm looking at. I'm looking at h prime, not h. So on what intervals is h decreasing? Well, h would be decreasing if h prime is negative. So h prime is negative from -2 to 3, but we're going to keep going because if it's just 0 for a split second, you include that point. So it'd be -2 to 7. Since we would say h prime of x is less than 0 on essentially -2 to 3 and 3 to 7. Okay. At which x values does h have a relative min? So we need h prime to change. So relative min looks like this for h. So we need h prime to change from negative to positive because h is changing from decreasing to increasing. So where does this graph change from negative to positive? At x equals -2, since h prime of x changes from negative to positive at that point. Okay. Here's a function. They say find all critical numbers for f, and then we're going to find where it's increasing, decreasing, relative extremi. Let's go. Okay, great. Let's find the critical numbers. First thing we got to do is find the derivative. F prime of x would be 2/3 times 4x squared minus 9 to the -1/3 times the derivative of 4x squared minus 9, which is 8x. That's the chain rule. Classic little chain rule problem. Okay, let's simplify it. F prime of x would be 16x divided by 3 times the cubed root of 4x squared minus 9. So f prime of x equals 0 when 16x equals 0, which means that, come on, which means that x equals 0. So that's a horizontal tangent. And f prime of x is undefined when the cubed root of 4x squared minus 9 equals 0. Cube both sides, you get 4x squared minus 9 equals 0. So 4x squared equals 9. X squared equals 9 fourths. So x equals plus or minus 3 halves. So the critical numbers of this function are at x equals 0 and at x equals plus or minus 3 halves. Okay. Now, it's interesting to note that I'm pretty sure this function is defined for all x element of the reals. So I don't think we have any asymptotes here, so we're going to need to deal with all of these critical points. So let's make ourselves a little sign chart here. Put x equals 0 as one of my critical points. I am going to put x equals negative 3 halves, which is negative 1.5, and I'm going to put x equals 1.5. So I've created 1, 2, 3, 4 intervals, so I need to find test values. So let's choose negative 2, negative 1, 1, and 2, right? Because I need to choose a test value in each one of these intervals to test f prime so I can see what's happening with f. So if I test negative 2, I'm going to get a negative over a 2 times 2 is over a positive. So that is negative for f prime. F is decreasing. If I plug in negative 1, I get a negative over a negative, which is positive. So f is increasing. If I plug in 1, I get a positive over a negative, which is negative. So therefore, f is decreasing. And if I plug in 2, I get a positive over a positive for my derivative. So it would be increasing. Now, how am I doing that? I'm plugging 2 in here, and I'm saying 16 times 2 is positive, and 3 times the cubed root of 4 times 2 squared minus 9 is also positive. So it's positive over a positive, which is positive. I don't really care what it equals to, but or what it simplifies to, but I know that it's going to be positive. I don't know why I said equals to, because you don't say equals to, you just say equals. In any case, that gives me a lot of information. So now I should be able to say that f is decreasing. I'm not sure why my pencil is not working, but it's decreasing. F is decreasing on the interval negative infinity to negative 1.5 and 0 to 1.5. And the function f is increasing from negative 1.5 to 0, and also on 1.5 to infinity. Okay, if I wanted to justify that, I would say this is because on these intervals, f prime is negative, and on these intervals, f prime is positive. Okay, so relative extrema for f, we would have a relative min at x equals negative 1.5 and x equals 1.5, right? Since f prime changes from negative to positive at those points. And we'd have a relative max at x equals 0 since f prime changes from positive to negative at that point. Okay. Okay, I wonder how much longer this is going to go. Not too much longer. Okay, okay, okay. Saving PDF. I've only got a couple more. Now it's taking longer though because it's saving. A couple more problems here. Consider this function whose first is given by, I'm guessing this is supposed to say first derivative. Okay, first derivative is given by this. Use f prime to find critical numbers. Well, one of them would be x equals 0, because that would be where the numerator equals 0. And that's going to be it, because the denominator is never equal to 0. X squared plus 3 squared does not equal 0. So this derivative is always defined. So x equals 0 is the only critical point. So all we need to do is check x equals 0. Okay, so we could test maybe -1 on this side and 1 on this side. If we plug -1 into f prime, we get a negative over a positive, which is negative. And if we plug 1 into f prime, we get a positive over a positive, which is positive. So therefore, f decreases on basically -infinity to 0 and increases on 0 to infinity. And f has a relative min. Actually, it's an absolute min. It's an absolute min because there's only one critical point at x equals 0, since f prime changes from negative to positive at that point. Okay, so yeah, anytime there's only one critical point, if there's only one critical point and it's a minimum, it has to be an absolute minimum, because there's no way to like turn back around and get to a lower place. Similarly, if you have one critical point that's a max, it has to be an absolute max. Okay, let f be a strictly increasing function such that f of x is less than 0. Okay, so that means that f of x is negative. Okay, for all values of x. So g of x be a strictly decreasing. Okay, so f of x is strictly increasing such that it's negative. Okay, and g of x is strictly decreasing such that g is positive. If h equals f times g, which statement is true? Okay, it looks like they want us to investigate whether h is increasing or decreasing, so we need to find h prime. Well, h prime would be f of x times g prime of x plus g of x times f prime of x, right? Because that would be the product rule. But what do we know? We know that f is negative. We know that g prime is also negative because g is strictly decreasing. We know that g is positive, and we know that f prime is also positive because f is increasing. So h prime is going to be a positive plus a positive, which is a positive. And therefore, we know that h is strictly increasing. Okay. So that is going to get rid of these, but now we need to figure out whether h is positive or negative. But remember, f is negative and g is positive, so therefore h is going to be negative. So h is going to be less than 0.